So, hello everyone. Today, the name of my project is audio classification and keyword spotting. In this project, I'm using machine learning model to classify audio signals and the keywords that I have created using the dataset. And final objective of this project is to deploy this model on an embedded device, that is a smartphone in my case. So the problem statement of the project is to first to classify the audio signals into various output labels. That is, we have three output labels in our dataset. That is first hello, second unknown, and third the noise. So we will take the raw data into the classifier and it will classify it into the three labels. Third is to create a model using CNN classifier and use MFCSE processing block to extract the features from the audio signals. Third is the deployment of this ML model onto an embedded device, that is smartphone. And fourth, to achieve the highest accuracy on the output model upon deployment. So the technical challenges that I faced during the completion of this project were first, uh, it was the collection of the data set, and moreover the rebalancing of that data set between the training and the test set. So I collected the data set and I evenly balanced it in the training and in the test data set, and the ratio between the training and the data set was 80 is to 20, that is 80% 80% training set and 20% test set. Second challenge was choosing the best compression technique for the model. So there are a few techniques that we have been taught in our course for compressions of a model, like the weight pruning and weight sharing. So I use the post training aware optimization technique for the compression. Third, adjusting of the hyperparameters of the model. So since there are a number of hyperparameters, such as number of filters, input length, input shape, everything. So changing those, we can uh, uh, adjust the parameters and get the highest accuracy. Fourth is to obtaining the spectrogram and the confusion matrix of the data set. That is, the method for obtaining the spectrogram, that is the plot of the features of the audio signals, and the confusion matrix that is obtained on the validation data set of a ML model. So the task of obtaining that was a challenge. So the related works that I found helpful during for the completion of this project were first an article called a depth-wise separable convolutional neural network by keyword spotting on an embedded system. So the article discusses methods for training and implementing a DSCNN-based KWS, that is keyword spotting system for low resource embedded platforms. Second was Edge Impulse. It is an ML development platform for deploying TensorFlow models on embedded devices. And third, I used Edge Impulse for collecting data, collecting the raw data. So I collected the raw data hello at a sample length of 30 seconds for a total period of 15 minutes, using the sensor microphone on my smartphone at a frequency rate of 16 kilohertz. So the approach for solving this project was first collecting data set and classifying it into training and the test data set. Second is to choose the correct CNN classifier. Third is to use the MFCC, that is mel frequency coefficients, for features extraction of the audio signal. Fourth is the optimization method, the kind of optimization method I need to choose. Fifth, the deployment using the Node.js software uh, on my smartphone. So the result of the project is the dataset was nicely balanced between the training and the test dataset, giving higher accuracy. The final model using the batch normalization, dropout layers, and the model compression technique gave an accuracy of 94.5% over the test dataset. And the confusion metrics obtained showed that the model is classifying nicely, giving above 90% accuracy on validation dataset for the three output labels. So the broader impact that I thought of this project was first the impact on voice assistants such as Google, Alexa, and Siri. So in today's uh, age, so the voice assistant has become an important part, connecting our phones and making calls, and everything gets done with the Google Alexa. Second is the demographic perspective of audio classification. That is, it has been found out that the audio classification or assistant technology is more prevalent among the younger people, and it has also been found that the region of Asia, is more welcoming and more interested in the enhancement of this technology, and accepting it into their day-to-day life. And third is the impact on modern lifestyles such as playing music or turning on and off lights and other home automation systems, that is really prevalent in today's age. So yeah, thank you.